The next idea that we're going to look at is this idea of converse theorems, and all a converse theorem is using the theorem in reverse. So normally we have a circle or some geometrical situation, and then we say, oh well, therefore this can happen. So what we're now going to do is say, well, something like this. A circle whose diameter is the hypotenuse of a right-angled triangle passes through the third vertex. So what am I talking about? If I've got a situation in geometry and I've got a right-angled triangle, then I know I can create a circle. Because A, B and C must lie on a circle. AB would end up being the diameter because of the theorem, angle in a semicircle. So it must be possible to draw a circle around all 3 points. Now, once I know that piece of information, that might open up some other ideas on how to solve the problem. Because now that I've got a circle there, I can use some circle geometry theorems maybe to help solve the problem. So I might not initially have a circle in it. The idea is, hang on, can I create a circle? And if I can create one, then it opens up more things that we could do. So I could say, yes, there's a circle there because we know an angle in the semicircle is 90 degrees. Something like this, where you've got a line and you notice that there's 2 angles that are the same coming from the same line. Then that, not only is it on the circle, but it's 4 points on a circle, which of course creates a cyclic quadrilateral. And we have theorems like, well, the opposite angles in a cyclic quadrilateral are equal, that we might be able to use, and then things like that. So here I could say, well, look, I know ABQP would form a cyclic quadrilateral, and the reason I'm saying is, well, look, we've got the situation of angles in the same segment. There might not be a circle drawn there, but we have, coming from the chord AB, 2 angles that are the same size. Perhaps we've got a quadrilateral and we notice that the opposite angles add up to 180. So again, we can say, this must be a cyclic quadrilateral. Therefore, it is possible to put a circle around it, use other circle geometry ideas. So here we go, I notice this one. Oh look, they add up to 180. So yep, A, B, C and D are concyclic. They must lie on the same circle because we know the opposite angles add up to 180. Okay, so just a couple of problems. Well, when I say a couple, how many is that? 1, 2, 3, 4, 5, 6, 7. All right, so handful and a bit of problems. So using that idea. This idea, for those of you who are thinking about extension 2, it's a very common idea that's used in circle geometry problems in extension 2, where they'll ask you to prove something's a cyclic quadrilateral, and then that will allow you to solve the problem via other ways. That's not to say it's restricted to extension 2. It's a little bit rarer in extension 1, but it does happen in extension 1. But extension 2, they love asking these sorts of questions.